Hey everyone, my name is Scott, and we're going to solve the factorial trailing zeros problem today on LeetCode. The problem definition is we're given an integer n, and we need to return the number of trailing zeros in n factorial, which, great, and everything, if we could just calculate n factorial straightforward, which we could do in linear time using dynamic programming. However, your solution needs to be logarithmic time complexity. So that kind of throws a kink in what we're going to do here. But the code is extremely short. I think it's about 7 lines, so it's not long. So we'll talk for a second about the math trick that makes this a logarithmic time complexity problem. So in general, if you want to know the number of trailing zeros of any number, what does that mean? The number of trailing zeros is the number of times you can divide that number by 10 and have it still be an integer. So for instance, say 1800. We divide it by 10 once, it's 180. It's still an integer. We divide it by 10 twice, it's 18, which is still an integer. We divide it by 10 again, we get to 1.8, which is no longer an integer. So we divided it twice by 10, and that means there were 2 trailing zeros. So that is the idea behind what we're going to do. Now, factorial is interesting because factorial, obviously, it's 5 factorial, 5 times 4 times 3 times 2 times 1 all the way down. So what we can do when we're calculating the factorial is, instead of calculating the factorial, we can count how many factors of 10 there are in the number. Okay, and that's easy to do. So think about it. Say we're working with 10 factorial. How many factors of 2 are there? Well, we've got 2, 4, 6, 8, and 10. Well, okay, well, how many factors of 5 are there? Well, there's 5, and then there's 10. 10 has a factor of 5, obviously. So we want to figure out how many factors of 10 are in this number. Well, to figure out how many factors of 10 are in the number, then all we really have to figure out is how many factors of 2 and how many factors of 5 there are in the number. 2 times 5, obviously 10. 10's prime factorization. So if we keep track of how many factors of 2 and 5 we have, then we know how many factors of 10 that we have, and we're good. We know the number of trailing zeros just like that. We have to also watch out there for numbers like 25 and 625 and so on and so forth. Things that are 5 squared, 5 cubed, 5 to the 4th, things like that, obviously, because they have multiple factors of 5 in them. And how are we going to deal with that? Well, we'll see. We'll go ahead and start writing the code out. And one thing to note is there's way more factors of 2 than there are factors of 5, right? Because every other number is going to have a factor of 2 in it. Every 5th number is going to have a factor of 5 in it. So what we really need to do is keep track of the factors of 5. And if we keep track of the factors of 5, we know that we'll have a factor of 2 for each factor of 5. And we're good there. So let's keep track of that count. Count's going to be 0, and we're going to loop. Well, n is not equal to 0. What are we going to do? What we're going to do is we're going to do temp is n over 5. And we'll explain this in a second. Our count plus equal to temp, and n is temp. And then we return the count. That is all there is to it. So here's how this works. So here's n, and we just said we need to know the number of the factors of 5. Because the number of factors of 5, each factor will factor with a factor of 2. 5 and 2 multiplied together gives us a factor of 10. A factor of 10 gives us a 0 on the end of the number. That's all there is to it. So we know that the individual factors of 5 will be n over 5, right? Every 5th number, there's going to be a factor of 5. However, what about factors of 25, which have 2 factors of 5 in them? Well, we counted it once, right? We already divided n by 5. If we divide it by 5 again, then we've accounted for the other factor of 5 in a number like 25. Or for 625, we divide it by 5 3 times, and we account for each factor of 5 in that number. So that's all we do. While n is not 0, we just keep dividing out 5, counting these factors of 5, and then adding in the numbers, the number of those factors that there are. And then when we're done, we know the total factors of 5, and we know for each factor of 5 there's going to be a factor of 2. Put them together, they make a 10. A 10 makes a 0 on the end of the actual number. And that's all there is to it. So again, just a problem that's got some tricky math behind it, but really nothing too crazy when you get down to it. So that's all for this video. Hopefully you learned something, and we'll see you next time.